Welcome back. To continue from where we left off, radiation does interact at the atomic and the cellular level and can be biologically damaging as it deposits energy in the cells of the human tissues in the body. Now, radiation can be deposited either in the cytoplasm of the cell or the nucleus of the cell. Because the body is made up of about 70 to 80% of water, the radiation is more likely to interact with the cytoplasmic water than the actual nucleus within the cell. Now, although the radiation is not directly interacting with the nucleus, changes in the cell that result from the interaction of the radiation with the cytoplasm can still damage the DNA in the nucleus. Damage to the DNA in this way is called the indirect effect, or sometimes referred to as the radiolysis of water. Radiolysis is the separation of the water molecule due to radiation interactions occurring. When the water molecule is disrupted, it forms ion pairs and charged water molecules such as HOH positive and a free electron. Now ions, they may rejoin to produce normal water, and if it does not, a free electron attaches itself to another molecule and it produces a negatively charged water molecule, HOH negative. Now these molecules are unstable, they're free radicals, because they have unpaired electrons in the outer shell, and therefore they are chemically reactive. The image to the right here gives you a picture view of what this is all about. It may not be very clear. It is in chapter 7 of the textbook on page 136 if you'd like to have a look at it there. When free radicals are produced, they can damage the DNA by traveling to the nucleus, and then they break the DNA bonds. Free radicals can also combine to form H2O2, which is hydrogen peroxide, and hydrogen peroxide is toxic to the cell and can lead to cell death. So once the toxicity is introduced into the cell, it cannot be undone and will lead to permanent biological damage. Mutations, increased cancer, birth defects, strokes, and cataracts can occur as a result. So to summarize, direct effects are biological damage that occurs as a result of ionizing radiation reaching the DNA within the nucleus, and this can cause the molecules to become inactive or functionally altered, and mutations can occur. Direct effects occur after exposure to any type of radiation, but it is much more likely to occur with high linear energy transfer radiation. X-rays are low linear energy transfer, which is less ionizing and less damaging than alpha. Its low linear energy transfer, because of this, it is more likely to pass through the substance or the tissue quickly, reducing the chance of direct effects occurring. Now let's look at indirect effect and summarize that. Effects are produced by reactive free radicals that are created by the interaction of the radiation with the water molecules in the cytoplasm of the cell. Now the unstable, highly reactive agents, which are the free radicals, have the potential to disrupt the molecule and result in cell death. This is a reference slide from the International Atomic Energy Agency, and they define the potential outcomes after exposure. Those potential outcomes to the cell could be damage to the DNA in three forms. It takes three forms. One is the cell can damage and repair itself. The cell could die. Apoptosis means cell death, or sometimes necrosis can be used as well. Or the cell could transform itself. It could heal but partially. It doesn't completely return to normal. And when it transforms itself, it's basically a mutation, and this mutation can lead to cancer. So there are a few questions I'd like you to answer as part of this lesson. When looking at this question, I want you to think about how all types of radiation are not created equally. High linear energy transfer radiation, which means it can deposit large amounts of energy in a small area per unit track or length of the tissue, and can completely break apart the molecule and lead to cell death. So high linear energy transfer is examples of what? Alpha, right? And beta radiation. And they are more hazardous internally when they are ingested or injected or inhaled. Internally, they can cause a lot of damage. Externally, alpha can be stopped by a piece of paper. So which answer would be correct here. Why is high linear energy transfer radiation of such great concern when it is ingested, injected, or inhaled? Would the damage be repairable or would it be irreparable? Also, make sure that you know how to calculate the relative biological effectiveness of a test of radiation. Remember, a relative biological effect can compare radiations with different linear energy transfers to determine its particular biological reaction. So make sure that you know how to calculate this. If it's not included in quiz 1, it will be included on your final exam. And based on what you know now, which one of these actions do you think is most harmful to the human body? The direct effect or the indirect effect, or is it equally harmful? These are the references for this lecture and presentation. Like I mentioned before, the textbook is now available through the CNAQ library. I've also used the International Atomic Energy Agency educational resources to compile this PowerPoint. And as I mentioned as well, there are free educational resources on the IAEA website. This will also help you most likely in creating reference documentation for your assignment. So this marks the end of our lesson. I wish you a good day further, and we'll chat again real soon. Bye for now.